Alright, so we're going to start talking with a bit about quantitative analysis, and we're going to go into it very, very briefly. You will be able to, if we're talking about one type of quantitative analysis in particular, you will be expected to understand this in quite a high level of detail, which is fine because we'll cover that when we do the experiment, which is here: identify data, plan, select equipment, and perform first-hand investigations to measure the sulfate content of lawn fertilizer. All right, so by the end of this, you want to be able to understand the point and the process of gravimetric analysis. Now, we have already done a bit of quantitative analysis. There are three types of quantitative analysis that we look at during this course in a super amount of detail. The first one we've already covered is volumetric analysis. Okay, so that's just titrations. Now, gravimetric analysis is as simple as this. Basically, what it is, we're using the weight or the mass, so therefore gravity, to analyze the amount of analyte in a sample. Now, analyte is just what we're measuring. This is often done by adding an excess of a reagent, which will precipitate all of the analyte out. So, for example, we would weigh the sample to be analyzed. So we've got our fertilizer, we're going to weigh it. We then dissolve it in water, not a problem. Okay, so we dissolve it all up, and we're trying to work out how much sulfate. I think let's check that, make sure it was the right one. Sulfate, yes. So we're trying to work out how much sulfate's in there. Not so hard. So we just put in a reagent that will precipitate all of the sulfate out. No drama. Now we add excess because we want to make sure that all of the sulfate is precipitated out. All of it. And that's really important. So however much of this reagent we add, it's not going to make a difference because we want the sulfate to be the limiting reagent, So then we filter it out. This is called a sinter filter, okay? And it's just basically, it creates a vacuum here, so you can see it off top. There's a water hose running there, which pulls all the air out and pulls it through here, creates a vacuum, and it's not a big deal. So that's our funnel. We've got our filter paper in there, and we just suck it out. Then we dry it. So you weigh it, you dry it. You weigh it, you dry it, and you keep weighing it and drying it until you've had several measurements where it's the same, where it hasn't changed. Okay, so you weigh it for several times until you've got a stable mass. Once you have a stable mass, you can then work out how much there is. So you can, using your mole formulas, you can then work out how much of the sulfate is there, which you're then able to work out how much of that, or what percentage of the original sample here is sulfate. So that's how that works. That's what we're doing there. Now, what are the advantages and disadvantages? First advantage is that it is useful for a large number of inorganic ions, and it can be super precise and super accurate. Okay, and the only limitation here is really our equipment. Of course, when we do it in a school lab, you'll see that it's not quite as perfect as it seems, but in a proper analytical lab, this is actually the most accurate way to do it. So it's accurate, it's precise, but as I said, in a lab, in a proper analytical lab, this is the most precise and accurate way we have. Disadvantages: co-precipitation. So if we're doing sulfate, there's always the risk of phosphates being co-precipitated out, okay, and that can throw off our things. So we've got to be a bit more careful, throw off our answers. It requires extreme cleanliness. The glassware needs to be perfect. It takes a long time, and it requires carefulness. So we're actually going to look at AAS, which is not as accurate. It's not as ideal, but it is much quicker. And that's it. That's gravimetric analysis. We'll look at it in a bit more detail in class, and we'll see you there.